Okay, we already talked about ionic bonds. Remember, ionic bonds are bonds that form when electrons are exchanged or moved. And then that creates a positive ion and a negative ion that are attracted to each other. Okay, that's one kind of bond. Remember, ionic bonds form between the metals and the non-metals. Okay? So today we're going to talk about covalent bonds. Covalent, co means with. So a covalent bond is a bond where electrons are shared. Okay? Covalent bonds are formed between a nonmetal and a nonmetal. So all these green guys and hydrogen. Because hydrogen is only over there in that first column because it has one valence electron. But it's a nonmetal. It just kind of got stuck over. That's the reason it's got its own color, because it's kind of a special case. So hydrogen is a nonmetal, and the nonmetals form covalent bonds. And I'm going to show you how we draw that. The first thing we're going to do is we're going to draw something called a Lewis structure. And when you draw a Lewis structure, you draw the chemical symbol for the element. So I'm going to start with hydrogen. And then you put in its valence electrons. Valence electrons are the electrons in the outermost shell. Those are the ones that are involved in bonding. Those are the only ones we're worried about. Okay, hydrogen only has one electron, so that makes it pretty easy. So what you do is you're going to, we did this in class once, you're going to pair those electrons around the element symbol. So that's hydrogen's electron, okay? And I'm going to draw oxygen. If you look on the periodic table, oxygen is in column number 6, which tells us it has 6 valence electrons. So I'm going to have one here, one here, one here, one here, one here, one here. I am going to move one of them. I'm going to put 2 down here instead.
You got to move one from the
I
right.
got 7 of them, don't I? Okay, so now I've got 6. 1, 2, 3, 4, 5, 6. Okay, so hydrogen and oxygen cannot form an ionic bond, but they can form a covalent bond. And what happens is, they share electrons. So I'm going to say that this is that hydrogen atom's electron, right there. And then I'm going to draw another hydrogen atom over here and its electrons. Now, both elements are stable because the hydrogen, they're sharing. And if it's a shared pair, then it counts for both atoms. Okay, a shared pair counts for both atoms. So hydrogen has 1, 2, and that fills up its outer shell, so it's happy. This hydrogen has 1, 2. It fills up its outer shell. The oxygen has 1, 2, 3, 4, 5, 6, 7, 8. 8 is the most that its outer shell can hold. Remember the octet rule? The octet rule says that An atom is most stable when it has 8 valence electrons, OCT 8. 8 valence electrons, or 8 electrons in the outer shell. The way that we write this even more shorthand is where there is a double bond, we turn it into a line. Like that. That is the same thing as the 2 electrons. And then we're going to put oxygen's other electrons. And that's how you draw a Lewis structure of H2O, which is water, as you well know. Okay? Let's do some more. So these are all covalent bonds. They're non-metals, they're sharing electrons. Okay. Chlorine. Chlorine is in the 7th column of the periodic table. It has 7 valence electrons. I'm going to draw another chlorine atom, and I'm going to make it in a different color. And you don't have to. I'm just doing this so you can tell the 2 chlorine atoms apart. And it's 7 green electrons and the 7 blue electrons. But these 2 chlorine atoms form a covalent bond, sharing these 2 electrons. And remember, if they're shared electrons, they count for both atoms. So this chlorine has 8, this chlorine has 8. They both follow the octet rule. They're both stable, both happy. Okay? So the way you would write the chemical formula for this, Cl2, because there's 2 of them. Okay, that little subscript means there's 2 of them. Chlorine is a diatomic molecule. Dia means 2, or di means 2 atomic, 2 atom molecule, diatomic molecule. Okay, we're going to do one more, and then I think hopefully that'll be good. Okay. Okay, I have carbon and hydrogen. This is called methane. This is what cows get a bad rap about, putting greenhouse gases into the air. So if you're going to draw a Lewis structure showing the covalent bonding in methane, you want to start with your central atom, and your central atom is going to be the one that it's there the least. Okay? There are 4 hydrogens and 1 carbon, right? So, carbon's going to be my central atom. Carbon is in the 4th column. Carbon has 4 valence electrons. 1, 2, 3, 4. I've got 4 hydrogens. Hydrogens in the 1st column of the periodic table has 1 valence electron. Okay, and that is the Lewis dot structure for methane, or CH4. And if we wanted to draw that using shorthand and get rid of the dots, remember 2 dots is equal to a line. More commonly, you see it written like this, with stick notation. Okay, and it all means the same thing.
methane have an E on the end?
What? Oh yeah, methane should have an E on the end of it. Daniel's here editing me. Okay, so just remember, covalent bonds, so sharing electrons. If there's a covalent bond, the electrons in the covalent bond are available to both atoms. So they count for both atoms. Okay? So that's how covalent bonds form.